Dear training officers, welcome to this session on hydrometeorological data collection, significance and importance. I am R. Thangamani, Director National Water Academy, Pune. I belong to the 1994 batch of engineering services and having 25 years of service in Central Water Commission in the area of water resources. In this lecture, I want to emphasize the importance of the data because the people who are involved in the data collection, both at central government as well as state government, always feel that they are not doing such an important job. But it is not so in reality. The data collected by them, how it is being used, how it is being analyzed, how it is being helpful in the planning and design of water resources structures, all these issues, and the further how we can improve it, that we will see in the present session. This is the most popular hydrological cycle which everyone knows from our school days. But here I want to emphasize 2 points, so I have repeated here. This is the detailed hydrological cycle. The whole hydrological cycle have the two important phenomena. One is evaporation and second is condensation. Condensation always follows evaporation. Here if you see this picture, evaporation takes place from ocean, from lake, from freshwater storages, and evapotranspiration from the trees and forest. Again the condensation takes both at the ocean as well as in the land mass. How we are connected with this one in this lecture is because we are collecting the meteorological parameters. The meteorological parameters are from evaporation to condensation to rainfall. That entire process is the subject area of meteorology. The moment the water touches the surface, then it becomes a hydrology. Central Water Commission, which is the apex organization in the field of water resources, is involved in the collection of both the data. This is the hydrological cycle which is represented in the another form. Here I want to emphasize one important point. See the ocean evaporation, ocean condensation, and evapotranspiration from trees, and again condensation and precipitation, evaporation from lakes and precipitation. If you see from the evaporation from the lakes, it is 9,000 kilometer cube, and the return flow as a precipitation is equal amount 9,000 kilometer cube. If you come to the evapotranspiration, the quantification is 65,200 kilometer cube. But if you look at it, when it returns as a precipitation, it is 1,10,000 kilometer cube. Almost 40% extra this evapotranspiration brings. Where from it brings? For that the answer is, look at the evaporation from the ocean. It is 5,02,800 kilometer cube, and the precipitation goes back is only 4,58,000 kilometer cube. This part of the evaporation is attracted by the trees and forests and brought to the land mass. That's why we always insist that grow more tree, grow more forest, in the sense that it will attract the evaporation from the ocean and transfer it as a precipitation in the land mass. This is the briefly what is meteorology. Meteorology is the study of atmosphere, atmospheric phenomena and atmospheric effects on our weather. The atmosphere is the gaseous layer of the physical environment that surrounds the planet. Up to atmosphere circle, atmosphere layer only, this temperature, this gas, everything will have a effect. So for the study of the rainfall and precipitation, this meteorology is essential. With regard to hydrology, hydrology is the science of water in the hydrological cycle and is concerned with its states, storages, fluxes in location, time and phase. As I told you already, till the rainwater touches the surface of the ground, that is meteorology. The moment it touches the ground, it becomes a hydrology. And hydrometry is the sister science which is concerned with the measurement of the various states in the hydrology. This is one of the important slide where we are going to discuss about what is the object of our meteorological and hydrological observations. How the data is being used one by one we will see here. The first one is the assessment of basin wise, sub-basin wise water resources. This is one of the main area where the data we collected is being used. Let us see how it is being used. This table shows the water resource potential of rivers of India basin wise. For the purpose of study, Central Water Commission has classified or categorized the basin into 20 basins starting from Indus, Ganga, Krishna, Godavari. If you look at it, the catchment area is 32,71,953 square kilometers and the water resource potential is the revised calculation 1999.2. How we arrived these data? These are all from the data from the hydrological data what we collect from our rivers. These data is only being used for the basin wise assessments. The next important area where the hydrometeorological data is being used is international issues arising out of transboundary rivers. Transboundary rivers means rivers flowing from one state to other state or one country to the other country. Let us have a quick look at India's position. This is the India map showing the various river basins. Let us start from the top where the Indus river from India it flows to Pakistan. It means we have a water sharing in the Indus ring with the Pakistan. For that water sharing treaty and implementation, we need the hydrometeorological data. Come to the Ganga basin. If you see the tributaries of Ganga, this Ghagra especially comes from the Nepal. So we have the water sharing with Nepal. The Ganga again flows to Bangladesh. So we have a water sharing treaty with Bangladesh. Bhutan, we have a water sharing. And if you look at the Brahmaputra flows from the Tibet and that river enters the Brahmaputra in India. So we have the transboundary water issues from here. So to solve all this issue or to make use of a agreement, we need the hydrometeorological data of these basins. The data of these basins which have international ramifications are called classified data. The data which flows within India, there are unclassified or non-classified data. These classified data are kept as a confidential and on request with the approval of the competent authority only we give to others. This slide shows about the whatever we have discussed. India shares waters with Nepal, Bhutan, China. China means that Tibet portion where the Brahmaputra enters India. Myanmar is again the Teesta river basin. Bangladesh and Pakistan. Nepal, Sarada, Kosi, Gantak. Bhutan, tributaries of Ganga for power projects. China, Brahmaputra. Myanmar, Manipur river and Chimtupi rivers. Bangladesh, Ganga, Brahmaputra, Meghna and Teesta. With Pakistan we have Indus water sharing. The next important use of this hydrometeorological data is in flood forecasting, inflow forecasting, reservoir regulation for dam safety. We will go one by one. Flood forecasting means forecasting either water level or reservoir inflow with respect to time. That is what is reservoir inflow is called inflow forecasting. Reservoir regulation means for operation of dams, that is based on the hydrometeorological data which we collect on a real-time basis. Flood inundation and development of mathematical model. For all these important areas, we use the hydrometeorological data which we collected. This picture shows the Pennar Basin network where the level forecast is being issued by Central Water Commission for the Nellore town, for which a series of hydrological and meteorological observation sites are established in the Pennar Basin. The data collected is being used for the level forecast of Nellore town. The next important use is provide necessary water resource data for better research, planning, development and management in the area of water resources. It is very vital that India is a country where there is a lot of variation in the spatial and temporal. Spatial means with respect to space. When one part of the country, Ganga basin and Brahmaputra basin is under flood, the southern portion is affected by drought. It means for better water management planning, we are using the data. Let us see one example here. This is the inter-basin transfer of water proposed under the National Perspective Plan. This study is being presently undertaken by the National Water Development Agency. If you look at the links, under this component, Himalayan components 40 links are proposed and the peninsular component 60 links are proposed. How they are proposing is these links. It is based on the water available study. For a water available study, what they are using? They are using the hydrometeorological data which we collect from our sites. So that way it plays a very important role in the water management and planning. The next one is preparation of detailed project reports. It means you have proposed that the water can be transferred from one basin to the other basin and this basin has a surplus. The moment you come to some conclusion that this has some idea, this has some extra water, then you cannot simply jump into the execution. You have to prepare a proper detailed project report which is shortly called DPR. For that purpose also, you need a hydrometeorological data. Let us see what we need. This is the slide which talks about the important aspects of DPR for water resources project. Central Water Commission has come out with important guidelines in the year 2010, which has the important chapters what a DPR shall contain. If you look at it, first chapter is interstate and international aspects, whether the project have any interstate or international ramification. Second is whether proper survey and investigation is been done. And third important chapter is hydrology. Hydrology means what? Whether that much quantity of water is available. How we decide about that much quantity of water available? It is based on the hydrometeorological data which we collected. So that way the data what we collect becomes important in preparing DPR. The next use is assessment of navigational potential for inland waterways. Now in the past few years you might be studying in the newspaper that ferry service have been started in the Ganga. In the inland waterways are being started used. So that way the data which we collect is being helpful. What data we collect? I briefly mentioned here water level in a river, discharge or flow data, rainfall data, climate data, in the sense sunshine, humidity, temperature, wind, evaporation, etc. Next is water quality and sediment. These are all the data which we collect in our CWC hydrometeorological observation site. Let us see how each data gains important in the coming slides. This is the one of the site T. Narasipura on Kabini River, which is a tributary of Kaveri Basin. Here just I have shown how we are measure water level using the gauge post. If you have to look at it, we are having a series of gauge posts where we measure the water level. This is another classical example of a water level measurement using gauge post at Tungabhadra River. CWC is having a site called Harlahalli on the main Tungabhadra. Now, this picture shows we not only measuring the water level using the gauge post, we have shifted to the automatic water level recording on a real-time basis. This is the one of the radar sensor installed at Nellore site, which is on the Pennar River. If you look at this picture, here this is the radar sensor. It sends the signal and it touches the water and come back. Depending upon the time it takes to reach back, we estimate the height up to which this point. And this is calibrated already. So when the fluctuation in water level, there will be a fluctuation in the recording. The advantage of this real-time water level recording is it records continuously at the frequency at which we want. Now let us go through quickly where this water level. It appears very simple. We are simply measuring water level only. What importance it is has? No, it is one of the important parameter. Though the observations is either manually or through radar sensor, it is simple, but the data is used for a very important purposes. Gives the preliminary idea about the situation. Whenever you tell the river level or water level at a particular point, it gives the, suppose today I am saying the water level in the particular river is 10 meter and yesterday the water level is only 9 meter. Then I understood that today we have got a 1 meter rise. So the water level is the one parameter where it gives the preliminary idea immediately. The next usage is useful in flood embankment design. So Central Water Commission and the Ministry of Jal Shakti is funding the flood management project throughout the country. When the proposal is submitted, they have to submit the flood embankment design and level also, because the flood level goes means the embankment design level also goes up. So water level plays a significant importance in the design of flood embankment. Next is helping in designing the withdrawal and outlet level. This is one of the important. You won't take a canal. You want to take water from the canal, from a river, and take it to your command area. So where you fix your level of the canal as well as the withdrawal point. So for that the water level is important. Useful in the flood forecasting. As I already told, the data which we collect plays a significant role in the flood forecasting. Let us see how it is being used. If you look at this slide, I will give you one simple example. Again on the Nellore site, which is on the Pennar River. Based on the water level, we fix the three levels: warning level, danger level and high flood level. So based on this level only, we issue the flood forecast warning to the state people. So water level plays a very important role. Next is useful in inundation mapping. This is the area, one area which gains very important in the recent times are, one is water level fine. But if the water level comes to up to this point, how much my area of the town or village will be affected? For that purpose, we have this inundation mapping. For that inundation mapping, this water level is being used. Useful in community activities. What is this community activities? Because wherever river is there, people are settled on the both the banks. You want to construct a ghat for the bathing or water utilization purpose of the people. Up to what level you have to construct the ghat? During monsoon season, the water level may come up during non-monsoon, the lean season, it may go down. So for deciding those community activities, you need the water level. The next important parameter is, or where the water level is used, is useful in fixing the deck level of railway and road bridge. For example, at a particular river, the water flows. You have planned to construct either road bridge or railway bridge. The deck slab of the bridge have to be kept above the maximum water level. Then only it will be safe during the flood season. For this purpose, we get lot of requests from the state governments always. Now let us see one example where it is being sought and given. This is the one of the request from government of Tamil Nadu. When I was working as a circle SC in Bangalore, Kaveri and Southern River Circle, the request was from the government of Tamil Nadu Highways Department for a hydraulic particulars of Chengalpattu site on Palar River. So it was sought on 2013. At the time the procedure is, we have to get the approval of chief engineer, then only we have to give the data. Now it is made easy and free also. Earlier they have to pay some nominal fees also. So this was the request from the government of Tamil Nadu seeking the data of Palar River. So as a circle AC, I conveyed the approval of the chief engineer to the executive engineer, because executive engineer only collects the money and gives the data. This is the final data what we have given to the government of Tamil Nadu. If you look at the picture, what they want is highest flood level and the corresponding discharge. The highest flood level on the particular CWC HO site was 29.5 meter on 14/11/1985, and the corresponding discharge is 3115. This data is being used by the Highways Department of Government of Tamil Nadu for their bridge design. So this is the one area where they use it. And sometimes what happens, in the almost some 20-25 years back, suppose CWC is not having a HO site on a particular river, and the concerned state government wants to construct a bridge. What they used to tell is, they request CWC, you establish a site for our purpose and collect the data and give us. So that is in our old terminology we call it MOT site, Ministry of Transport. It means the sites which we established based on the Ministry of Transport is called MOT sites, but now that nomenclature is no more available, because almost all rivers we are having site. Next is for navigation. This water plays an important role in navigation. So you might have observed last year during the flood in Ganga, where the low level area or the delta area was affected by the flood, the area near Varanasi, they were all, the people who are involved in the navigation, they were all happy, because there was sufficient water level where they can do the ferrying. So for navigation purpose, the water level is very important. Next is for coastal protection. Coastal protection in the sense, the height, the crest level of the protection structures have to be above the safe level, and many more indirect usages. The listed uses are very minimum only. There are many more uses. This is the discharge measurement of our Beligundu site on Kaveri River. The significance of discharge measurement. This is one of the very, very important data which CWC is having for last so many years. This is one of our asset, the authentic data, and Central Water Commission is the only department which does it in a full-time scale. In all other state governments and all, the concerned agencies who are involved in the data collection are vested with the other works also, because of which their importance in the data collection becomes considerably reduced. Let us have a quick look at where the discharge measurement is being used or how it is significance and importance. First one is, it gives the volumetric details. Yes, If you want to know the quantity, you have to measure the discharge. Rate of runoff. Rate of runoff in the sense, it not only gives volume, it gives volume with respect to time also. How much it goes in a unit time. Useful in design of storage structures. Because based on quantity only, you design your storage structure. Based on your rate, you design the outlet structures. Next is useful in sharing of water in the interstate and international rivers. All of you may be very much aware that on all the interstate rivers, the tribunals are formed, the river management boards are formed. So, for sharing the waters, we need this vital data of discharge. Useful in flood forecasting, this we discussed. Useful in the erosion control measures. How it is helpful in the erosion control measures? For example, for erosion control measures, the rate of discharge is very important. If the huge quantity comes within a short time, it erodes the both banks and goes. When it erodes, it takes away a lot of silt also. So for erosion control measures, we need the data. Useful in flood embankment design. Useful in the inundation mapping. This along with the water level is useful. Useful in reservoir operation. It is very, very important usage of the discharge measurement. Because based on the incoming flow only, you decide the how much water I have to let it into the river or how much I have to open the gate. So for this purpose, the discharge measurement data is being used. As all of you may be aware that we collect the discharge data daily at 8 a.m. This is the rain gauge evaporimeter temperature measurement at CWC site T. Narasupura on the Kabini river, which is the tributary. What we are seeing here is the pan evaporimeter, rain gauge, Stevenson screen where the thermometers are installed. This is the telemetry station of CWC where you are seeing the automatic rain gauge. The data is collected once in a 15 minutes and we can change the frequency as per our requirement. And this is the telemetry, this solar panel. It is connected with the water level of the river. So this water level and rainfall data is transferred to the modeling center on real-time basis. How this rainfall is significant? We all know that rainfall is the base for discharge. If there is no rainfall, then there is no discharge. The next question comes, I am measuring discharge, then why I should measure rainfall? Because there are some basins where we don't have discharge measurement stations. On such stations, using the rainfall, we are calculating the discharge. And second point is, establishment of a hydrological observation site for measurement of discharge is not so closed network, whereas rainfall you can have a very close network whereby you can estimate the discharge. And next one is helpful in knowing the spatial and temporal variation of the distribution of water. What is this spatial? As we discussed earlier, space means with respect to space. How much water is there in Ganga basin? How much is the rainfall in the Narmada basin? So you know the spatial variation. Again, within that particular place or within that particular space, how it varies with respect to time. To know that one, you need the rainfall. Next is rate of runoff. When you estimate the runoff, you estimate through the rainfall. Useful in design of storage structures. Useful in flood forecasting. Same usages are repeating. Useful in inundation mapping. Useful in weather forecast. Useful in reservoir operation. How it is useful in reservoir operation is because you are measuring discharge. Based on discharge, you are operating your reservoirs. Suppose you know how much rainfall happened in the upstream catchment. You can estimate that discharge due to that rainfall also. You can add it in your reservoir operation schedule. This rainfall is measured twice in case of manual rainfall, morning 8:30 and evening 17:30. And in respect of automatic rain gauge, every 15 minutes it records. The other parameters which measures are sunshine. Sunshine means sunshine we record in the hours, number of sunshine hours, humidity and temperature. These plays important role in the prediction. Though CWC is not involved in the prediction, these data are very much useful in calculation of the evapotranspiration and crop water requirement. Nowadays what happens, in the advent of, you all may be aware that 80 to 85% of water is being used for irrigation. So if at all you want to conserve water, the irrigation requirement has to be drastically improved by improving the efficiency. For improving the efficiency, we adopt modern technology like drip irrigation, sprinkler irrigation, pipe irrigation, and these schedules are based on the crop water requirement, how much the crop needs. You don't simply pump the water, you don't simply supply the water. For calculation of these crop water requirement, these data are very much essential. Next is wind. Wind data is being used for, one is production of wind energy, second is effect of wind on the velocity and discharge. Those who involved in the discharge measurement might be aware of it. For example, I will quote simple example. Today for the gauge of 5 meter, my discharge is 170 meter cube per second. Suppose yesterday for the same 5 meter, my discharge is 150 meter cube per second. Then you have a doubt whether which data is correct, either yesterday data or today's data. In such cases, if you immediately refer the wind direction and wind velocity, you will get a very good idea. In the case of 170 meter cube per second, the wind might have been blown along the direction of the flow. In the case of 150 meter cube per second, if you refer it, the wind might have been blown opposite to the flow direction. The next question comes whether wind has so much effect. Yes. So after comparing the wind direction only, you should further proceed with regard to the accuracy of the data. So wind plays a important role. And next is the one reason I told, morning we measure the discharge at 8 o'clock in the morning. One reason is because I had measured when we go for joint inspection, when we reach the site which are far off places, when we reach itself, we may reach around 10:30 or 11. So we conduct a second observation. When we conduct the second observation by around 10 o'clock or 11 o'clock, you know the wind direction and the wind speed very different, and it is very difficult to anchor the boat also when the wind velocity is very high. So this wind data is being used accordingly. Next data is evaporation. It almost all our FCS stations we are having this pan evaporimeter. It uses it gives the idea about the loss of quantity of water due to evaporation, especially in the location where the reservoirs are constructed. We will come to know in the very certain places even some evaporation control measures also being undertaken using the evaporation data. This is the quick classification of the lab, CWC, level 1 lab, level 2 plus or 3. Level 1 is the site lab and level 2 is division office. Level 2 plus or 3 is our office located at the headquarters of the chief engineer office. We will go through quickly. This is the water quality stations in CWC. This is one of the asset CWC that we have a wide network throughout the country. The level 1 lab. Level 1 lab means we measure those 6 parameters. Level 2, 2 plus and 3 lab. This is just for your information. We will quickly pass through. Significance of the water quality measurement. This I did not tell, but still we will repeat it. Helps in identifying the fitness of water for various usages like domestic and industrial use. So this plays a very important. What is the quality of water? So far the data which we collected talked about only the quantity. That at some places the quantity may be available, but the quality will not be fit for our usages. Next usage helps in preserving the water quality to the required standard. For example, when we compare the water quality data, suppose 10 years back the quality is different and the present day the quality is different, then we can come to some conclusion that quality is either improving or it is decreasing. We can take some measures. Helps in preserving the aquatic system. Aquatic system in the sense the fish and other marine living beings. For examples, especially the fish, when the dissolved oxygen goes below 4 pm, it cannot survive. So if at all you want to maintain the ecosystem, you have to maintain certain level. So this data helps that one. With regard to cerebral sites, we have 3 categories. Base station, where the sample is collected once in 2 months. Trend station means once in every month. Flux station means thrice in every month. It means once in 10 daily. So depending upon that quality fluctuations, we collect the data and analyze. This is the basic parameter I told. Level 1 lab, color, odor, temperature, pH, specific conductivity and dissolved oxygen. This we measure in all our level 1 lab, or we call it as a site lab. Next important data which we collect and widely used by all the people of water resource sector is sediment, because no other department is measuring sediment so accurately like Central Water Commission. We does it as meticulously. How the sediment is helpful. For example, first, how the sediment or where from it comes. We all know that the sediment comes from the catchment area of the basin. Again, the sediment is nothing but the soil particles. Once the sediment reaches the river, it never goes back to the catchment area. And soil is not a renewable resources. It will not come every year. So whatever the sediment which we receive through river and finally it reaches the ocean means that lost is lost. For creation of 1 tons of earth, it takes thousands of years. So it is our duty to prevent the sediment erosion. Now let us see, go one by point. How to identify and quantify the sediment deposit in the water storage structures. It means I am constructing a dam or reservoir. What happens? All the water comes in the river. It is stored. The moment the velocity is reduced, what happens? The particle it carried, it starts settling in the reservoir. It means it occupies the storage capacity of the reservoir. So whenever we design a dam, we take into account the sediment quantity also. If I am not taking into account the sediment quantity, what will happen is, I will construct the dam for the storage of water. If I am not designed properly for sediment, after many years, the dam will be entirely filled with sediment only. Then my very purpose of the dam will be defeated. So you have to keep the provision for the sediment also. Next, helps in identifying erosion control measures. As I already told, sediments are very important resource. We cannot simply allow, okay, let it come and settle in my reservoir. We have to control it. One of the important control measure is the afforestation, planting trees in the catchment area. Next is helps in watershed development. It means we find that this particular area, the erosion is very significant. So the sediment rate is very high. Then we recommend for watershed development of that particular area. The grain size distribution of sediment helps in designing the turbines of hydropower plants, especially for the hydropower plants in the northeastern region and Himalayan region. What happens? The particle size are very heavy. So the turbine also to be designed to take care of those bigger particles. Helps in design of water treatment plants. Again, because in the water treatment plants, when you allow the water to pass through, these sediments have a significant effect. In CWC sites, suspended sediments are observed daily along with the discharge measurement, and this data is very frequently sought by the people who design water resource structures. This is one of the full climate station at CWC site Morapanadu on Tamrabarani river. It has the complete set of data. If you are having pan evaporimeter, automatic rain gauge, here standard rain gauge, that Stevenson screen, the sunshine recorder. So it's a complete FCS station. Now this is everybody knows who uses the data. So few of the things I have listed here: State Water Resource Development, CWC, IMD, Pollution Control Boards, Water Supply Boards, Geology and Mines Department, Hydropower Corporations, and Industry. It goes Agriculture Department, Fisheries, Forestry, Roads Department. I have shown one example how the Roads Department collected the water level and discharge data of CWC site. Railway developments, again for the same purpose, bridge design, drought monitoring cell, tourism boards, universities and research institutes, remote sensing agencies, Ministry of Transport, Environment and Forest, and Ministry of Defense. All these people uses our data, and lot of NGOs also. Now what happens? CWC is not charging any charges for the data. It is on free of cost. So people started using widely for research and other purposes. This picture shows our HO network, which is the very great strength of CWC. Up to last year, we have our total strength of HO site is 1626, and as on November 2019, we have 1707 sites, which is the great backbone of CWC. It means almost 1700 sites. Central Water Commission is collecting data on daily basis by a meticulously dedicated staff. That is our greatest strength. Okay, we collected the data. For whom we are disseminating? For internal CWC officers, for concerned basin states, whether they are demanding or not demanding, we give them the copy of the data so that whenever they need it, they are using it. Both hard copy as well as soft copy we give. Data also placed in the India Virus portal for the interested individuals. Friends, we have come to the end of the presentation. Hope you understand the importance and significance of the hydrometeorological data. Though many people do not appreciate what we are doing in the HO site, but the significance and importance will give us a proud that I am contributing for the water resource development of the country. With this, I wish you all the best. Thank you so much.